Okay, good morning to all. Now I am going to start the class. Today's topic is we are going to discuss the ray optics. Sorry, it's not ray optics. We are going to discuss about the wave optics. Chapter I am going to start. We already discussed a few topics in wave optics, and that are the wavefront Huygens principle. Later we discussed about the path difference, phase difference, coherent sources. A few topics we discussed, that is the verification of reflection and refraction of plane wavefront. Today's topic is very important for the board exam, and you listen very carefully. Now I am going to start the Young's double slit experiment. This is my topic, right? I am going to start Young's double slit experiment. This experiment is very important for the exam, and you will get the 5 marks based on this. Okay, this topic is very important for the 5 marks. Long answer question. They will ask to derive the conditions for the bright and dark bands in the interference pattern. Now, is it clear? Writing and picture, voice, anyone can test the message. Now, Young's double slit experiment is our topic, and now how to write, how to go for this one. Let us see here, and for this, let us take the light rays. This is considered as a source, is a source of light. And now this is a cardboard with two holes. Okay, this S1 and S2 are called as the slits. And let us take here one screen. This is a screen, and these are the two slits. S1, S2 are the slits. S1 comma S2 are the slits. Slits means what? Opening. Okay, through that light will passes. And here this is said to be a cardboard. It's a cardboard with two pinholes. Okay, cardboard with two pinholes. This is a source. S is a source. Okay, and this is a cardboard, and this is a screen. This is the setup for the Young's double slit experiment. We require a source of white light. Okay, and in front of that there is a one cardboard we will place, but through the cardboard the light never passes. We have to make the two pinholes, and these two holes, through these two holes light passes. Then that's why uh, these two sources will act, these two slits will act as sources, because through that the light will emits, and that light which is emitting from the S1 and S2 are superposed on the screen. Due to the superposition on screen, you will observe the alternative bright and dark bands. Let us see and how you will obtain the alternative bright and dark bands. And for the purpose, we will take the two light rays. Okay, for example, like this, the light ray started, and the light rays will passes through the slits. For example, this is the center of the screen. This is the center of the screen. This is the center. O is the center of the screen. Okay. O is the center of the screen. You see here, what is O? O is the center of screen. O is the center of screen. Very important topic, and you listen very carefully. And here the light started from S1 is an opening. S1 is an opening. It is a slit. It's a cardboard. The cardboard blocks all the letters which are inserting it here, but except two openings. Through the two openings, light passes. And for example, the light started from S1. It will travel in all the directions, right? I'm taking the light wheel in the one direction, and that two letters are meeting at one point. Okay, we will take like this. The light rays are meeting at point P at here. This is a point P we consider. And here not only at point P, light will travel in all the directions. Due to that, light will meet at here also like this. See here, the light is meeting at point P. Along with that, light can travel. You see the diagram, the cursor is moving. From the S1, the light started and it will meet at point O. From S2 also, light will start and it will meet at point O. Like this, the light which is starting from S1 and S2, okay, and then they will meet at every point on the screen. Like this also light will travel, right? And from here also light will travel, and they will superpose it here, and due to that they will get the alternative bright and dark bands. Okay, and now you see very carefully at here. If you have any doubt, you can test me. And is it clear till now, whatever that I am teaching? Okay, now what is the O is the center of the screen completed. S1, S2 are also said to be coherent sources because they are originating from single source. That's why we can say that they are the coherent sources. S1, S2 are the coherent sources. S1, S2 are the coherent sources. Coherent sources means what? These sources are originating from single source. Okay, these two sources S1 and S2 are split from only single source, right? And that too, if the phase difference between the two light rays which are emitting from the sources is constant, and the light rays having the same frequency, then such sources are said to be coherent sources. And now let us see here that the first light wave, this is the first light wave whose displacement we can consider as y1. This is the second light wave, its displacement we can consider as the y2. Okay, and these two are meeting it here. Due to that, here you may get either bright or dark bands, but at the center we will get the bright band. At the center we will get the bright band. This is the bright band. At here we will get like this, and the next dark band we will get. Next bright band we will get on the screen. Next either bright or dark band you will get here like this. On the screen you will observe the some bright and dark bands. This is again bright band. This is one more bright band. Like this on the screen you will observe the some bright and dark bands. Okay. Now if you observe this one, at the center of the screen you got the bright band. At the center of the screen you got this bright band. This is the bright band. Next one is the dark band. Next one bright, dark, bright, dark, bright. This white one is the bright. Okay, white one is the bright. and then the middle one is the dark. Like this, you will observe on the screen bright and dark bands. This is the dark, bright. Okay. On the screen, you will observe the alternative bright and dark bands. The dark and this the bright. Like this, you will observe. At the center, what you are getting it here, bright band we are getting. Okay. Now, let us see here. And we have to write the displacements of the two light waves equation. And for that purpose, first light wave, let us consider as I naught is the intensity of light emitting from sources S1 and S2, and A1, we can take the here the from the S1 source the light is emitting, its intensity we can consider as I naught, and from S2 source also light is emitting, its intensity we can consider as A naught, I naught, and AV is the amplitude of each light wave which is emitting from here, the intensity of each light, which is each light wave emitting from sources S1 and S2. A is the amplitude of each light wave. Amplitude of each light. Okay. Amplitude of each light wave which is originating from S1 and S2. Okay. Two light waves are originating it here. The two light waves are originating from the sources S1 and S2, and they are meeting at point O. Okay. We will write some points at here. Okay. Two light waves of each amplitude A. Some sentences we write here. Two light waves each of amplitude. Two light waves each of amplitude A and intensity I naught are originating from two slits S1 and S2. These two light waves these two light waves has phase difference. Let us consider these two light waves has phase difference phi. Due to the interference on the screen, these two light waves are interfere means what? Due to the interference of these light waves on the screen, due to the interference on the screen, alternate bright and dark band forms. Alternate bright and dark bands forms with central bright band. With central bright band. I will explain this sentence, whatever that I am giving it here. You listen very carefully. You see the diagram. This is S1 source and this is the S2 source. From the sources, the light will be emitted. Two lights. The two lights are superposing on the screen. Due to the superposition on the screen, you may observe here bright band or dark band. Why? Because here the light is started and here the light started. The two lights are superposing it here. If that superposition is only called as interference, right? The superposition, the phenomenon of superposition of two light waves, right? And that is called as interference, or simply, or we can also say that the phenomenon in which the redistribution of light energy takes place due to the superposition of light waves. Redistribution of light energy means here, for example, light rays are coming from here, they are superposing it here. Here, the bright band is forms. It may be it forms dark band also. That is depends upon the path difference between the two light waves. Okay, and that is depends upon the phase difference. If the two light waves are interference constructively, superpose constructively, bright band forms. If destructively interference, then dark band will forms. That is depends upon the path difference, right? And now two light waves are there here. They are originating from the sources S1 and S2. The two light waves have the same amplitude A, and the two light waves have the same intensity I naught. They are superposing with each other at point E. Okay, right. And now, due to that, on the screen you will observe the alternative bright and dark bands. Not only the light rays are reaching at point P, at every point on the screen the light rays will be meet. If you observe example here also, you see light ray coming from S1 and light ray coming from S2, they are meeting it here, and due to that interference, due to that alternative bright and dark band will forms on the screen. Okay, here this is a bright and this is a dark, bright and dark, like this forms in the center bright band. This is the center. O is the center of the screen. On the center of the screen, what will forms? Bright band will be formed, right? Now I am going to rub the right side. If you have any doubt, you can ask me here directly. Okay. Now let us start and let us continue. And the derivation I am going to explain. The derivation is important for the 5 marks. Very carefully. Then in the waves chapter we discussed the in the waves chapter we discussed the how to write the displacement equation, first light wave equation. Every step very important from here. Okay, and that theory is not important, but whatever the derivation I am doing, that is very important. First light wave equation, first light wave equation, we can take as the y1. Y1 is equal to what we write? Y1 is equal to we write as a, we know the light wave equation that we write as a cos omega t or a sin omega t we write. This is equation 1, first light wave equation. Second light wave equation I am going to write. The second light wave equation is y2 is equal to, we write as a cos omega t plus phi. Okay, the two light waves are coming from, you see the figure, one light wave coming from the S1 and one second light wave coming from S2. Their displacements I am considering as y1 and y2. We can express the light wave equation. Wave equation in the first, second, 11th class we discussed. You have to express either sine or cos. That's why y1 is equal to a cos omega t I took. Y2 is equal to a cos omega t plus phi I took. What is a? We know a is the amplitude of each light wave, and omega is the angular frequency. Omega is angular frequency. Omega is the angular frequency, and that omega formula we have 2 pi nu. 2 pi nu. Nu is the general frequency, and A is the amplitude of each light wave. A is the amplitude of each light wave, amplitude of each light wave. And what is omega? Omega completed. What is phi? Phi is the phase difference between the two light waves. Phase difference between two light waves. Phase difference means what? Phase is nothing but angle. What is the angle of the first light wave? Omega t. What is the angle of the second light wave? Omega t plus phi. Difference in angle you find out omega t plus phi minus omega t. You see the equation 1. First wave angle is omega t. Second wave phase angle is omega t plus phi. The difference in phase angle, phase difference is nothing but omega t plus phi minus omega t. You will get as phi. That is the phase difference. Phase difference between the two light waves. Okay. And now what are the y1 and y2? Y1 and y2 are what? Y1 and y2 are the displacements of two light waves. Displacements of two light waves. Okay, right. Now these two light waves are superposed with each other according to principle of superposition. What we write? According to principle of superposition, right? Interference means what? Young's double slit experiment is for the interference. In interference, what happens? Interference is nothing but superposition. Two light waves which are originating from the sources S1 and S2, they are superposed with each other. That is called as interference. And according to the principle of superposition, according to the principle of superposition. Actually, this topic is linked with the previous topic. I said many times that you watch the previous lecture, you watch the previous lecture. Its continuation we will discuss. Like that I told, even though you not practiced, that is the problem that you may not understood few steps, right? And then according to the principle of superposition, what we write the equation? We write as y is equal to y1 plus y2. Okay, and this we substituted here. Y is equal to y1 is what? Okay, y1 is the a cos omega t, and y2 is what? A cos omega t plus phi. Okay, and what is the principle of superposition? Principle of superposition, that it will give when two light waves are superposed with each other. The light wave which is coming from S1 and S2 are superposing. According to when the two or more light waves superpose with each other, the resultant wave displacement is equal. This y is the resultant wave displacement, that is equal to sum of displacements of individual waves. Individual waves are the y1 and y2. Then sum of displacements of individual waves you will get. Next, I am going to erase this and I will continue. You take the screenshot and note it. I am going to erase on the right side. You write in the comment box if you have any problem, and if you have doubt in any step, you can try to clarify immediately, because this is very important. What we are doing it here? Actually, in Young's double slit experiment, practically he observed the interference pattern. Interference pattern is what? When two or more light waves are superposed with each other, then based on the superposition, right, either bright or dark band will be forms. Okay, if the superposition is constructive, bright band will be forms. If the superposition is destructive, dark band will be forms. Okay, then on the screen you will get either alternative bright and dark bands. On the screen you will observe the alternative bright and dark bands. Then here, what we are going to do in this chapter, in this topic, we are going to do that we are going to derive the conditions for the bright band, when bright band forms and when dark band will forms. On the screen we are observing like these all things, right? That conditions I am going to derive, and I am also going to derive that when two light waves are each of amplitude a are superposing it here, what is the resultant intensity and resultant amplitude is what, that I am going to explain. And for the purpose, you see here, according to the principle of superposition, we got something that is a resultant wave displacement. The resultant wave displacement y is what at here? Resultant wave displacement. Resultant wave displacement. resultant wave displacement. Two light waves displacements are y1 and y2. Then two light waves are combined and forms a new light wave. The new light wave displacement is y. We got y is a cos omega t from the previous equation plus a cos of omega t plus phi. Now we have a mathematics formula. We can common the a here. When you common this, first I am going to write this. Okay, cos of omega t plus phi plus cos omega t. Just I wrote the second term as first term, no problem. And here in the mathematics, there is a formula is there. That is cos c plus cos d is equal to cos c plus cos d is equal to, okay. It is equal to 2 cos c plus d by 2. 2 cos c plus d by 2 into cos c minus d by 2. It's a mathematics formula. In the trigonometry it will be there. And this formula I am using it here. If we use this formula, what you will get in the next step? Okay, let us see here. And let us continue. Then this we will take as a C, this we will take as C, and this we will take as D. Okay. Then what you will get the next step? The next step we will get as y is equal to a into, sorry, first a is there, a is a, right? 2 into cos c plus d by 2. C plus d by 2 is what? C is omega t plus phi plus d is omega t by 2 into cos c minus d by 2, c minus d by 2. That is c is omega t plus phi minus d is omega t, c minus d by 2. Then let us simplify it. And then what you will get? Okay, that is y is equal to 2a into cos. This we write as omega t plus omega t, 2 omega t you will get plus 5 by 2. If you simplify this in this next step, we will get as omega t plus 5 by 2 into cos 5 by 2 we will get. This we will write like this. Y is equal to 2a cos 5 by 2 into cos omega t plus 5 by 2 we write. But here this we write as, we can consider as capital A. Then we will write as capital A into cos omega t plus 5 by 2 we write. This is equation 3. Okay, right. What is capital A in this? What is capital A? Look at here. The first light wave equation is A cos omega t. Second light wave equation is A cos omega t plus phi. Y1 equal to A cos omega t. Y2 is equal to A cos omega t plus phi. There are two light waves are there that are originating from S1 and S2. They are superposing with each other. And the first light wave equation is A cos omega t. Second light wave equation is A cos omega t plus phi. And that two light waves are superposing with each other. Okay, and the resultant light wave also just like a cos omega t only. Here we got as this, we can consider as capital A. You see very carefully, and this I am considering as capital A, right? Okay, this is the capital A. Now we write a capital A into cos omega t plus 5 by 2. This capital A is what here? The capital A is the resultant wave amplitude. Y is the resultant wave displacement. Y is the resultant wave displacement. Then that is equal to resultant amplitude into cos. Because generally equation is y is equal to a cos omega t. And that a is the amplitude. And here also y is equal to a cos omega t, where capital A is the amplitude. But y is the resultant wave. Once two light wave, after two light wave superposition, you will get a new light wave. That new light wave displacement is y. Here the capital A is the new light wave amplitude. New light wave amplitude. New light wave, the resultant light wave, how it will be generated when two light waves superpose with each other, then combine with each other, the new light wave forms. The new light wave displacement is y. New light wave amplitude is I. Here the two light waves are in the figure. You see one light wave is coming from S1, Other light wave is coming from S2. The two light waves are superposing it here. The resultant light wave displacement here, resultant light wave will be produces. The resultant light wave displacement is Y, and resultant light wave amplitude is capital A. Right? Okay. And now, if you have any doubt, you can test. Are you till now? Is there any doubt? Then you can comment. Any problem? Anyone have the problem? You can tell me. While teaching, you can write in the comment box. I will clarify. Okay. Now I am going to continue and you listen very carefully. I think till now everything is clear, and then I am going to continue. I am going to erase on the right side. What I want to do in the Young's double slit experiment, what happens? It's an interference experiment. Interference means two light waves are superposed with each other. Due to that superposition, what happens? Alternative bright and dark bands will be forms. Alternative bright and dark bands will be forms. If the superposition is constructive, the bright band will forms. If the superposition is destructive, the dark band will be forms. Right? Now, the concept clarity is important, and this is important for the long answer. You can test the message if you have the doubt. Anything you can ask. Anything you can ask. Okay, let us start. Let us continue. And now, very carefully, you have to hear. Last step is what? Resultant wave displacement we got. What is the resultant wave displacement? Okay, from equation 3, we write resultant wave amplitude also. The resultant wave amplitude is from equation 3, resultant wave amplitude. Resultant wave amplitude. What is the resultant wave amplitude? Resultant wave amplitude is capital A. That is equal to, from the figure, from the previous derivation, we got is 2a cos phi by 2. Okay, this is equation 4. This is the resultant wave amplitude. And the resultant wave intensity is what? What is the relation between the intensity and amplitude? This first light wave have the amplitude A and intensity I naught. Second light wave also have the amplitude A and intensity I naught. The two light waves are superposing with each other. Here we will get the resultant intensity. The resultant intensity we can consider as I, and the resultant amplitude we can consider as A. And then what is the resultant amplitude and what is the resultant A? Resultant amplitude is what that we are going to derive. Resultant amplitude is A. A is equal to how much we derived, and resultant intensity is I. What is the relation between the intensity and amplitude? Anyone can test the message. Resultant light wave intensity. Can anyone tell? Right. Resultant light wave intensity is I is equal to, we will get is resultant light wave intensity is equal to square of resultant amplitude. We know the relation between the intensity and amplitude. Intensity is equal to square of amplitude. Then here previously we got the amplitude equation, right? We substitute here 2a cos phi by 2 from the equation 4, right? Whole square. Then what you will get the I formula? I formula will get as 4a square cos square phi by 2 we will get. You see here. And in this we write here, what is a square? What is a square? A square is the, but a square is the intensity of each light wave. Is it right? A is the amplitude of each light wave, means I naught is the intensity of each light wave. Two light waves are superposing it here. In that, intensity of each light wave is I naught. Then final formula we will get as I is equal to 4 I naught cos square 5 by 2. This is the resultant intensity. Okay, resultant intensity. This is the formula for the resultant amplitude. This is the formula for the resultant intensity. When two light waves each of intensity I naught are superposed with each other, then the resultant light wave intensity is, okay. Look at here, very simply it was this is the source. Okay, it started it here, and on the screen at every point light will be meet. Here also light will meet. Okay, and here uh, this is the first light wave. This is the center of the screen. You see here at the center of the screen, the lights are coming from two sources S1 and S2, and they are meeting it here. Then this light wave have the intensity I naught, this light wave have the intensity I naught. After superposition, the resultant light wave intensity is I. I is equal to formula we have is 4 I naught cos square 5 by 2. Like this, at every point on the screen, the light rays will be meet. Okay, like this, like, because the light travel in all directions. That's why at every point on the screen the light will be meets, and then you will get some alternative bright and dark bands on the screen based on the superposition. If the superposition is constructive, then the bright band will forms. If the superposition is destructive, dark band will be forms. Let us derive the, this is the resultant intensity formula we derived it here from equation 5, and I want to write the finally condition for the bright band and condition for dark band. With that, this long answer will be complete. When the bright band will forms and when the dark band will forms. It will complete, then this topic will complete. What formula you got here? Resultant intensity formula. Resultant intensity formula, what you got? Next, I am going to write the one thing, that condition for bright band. What is the condition for bright band? On the screen, bright band when will forms? Condition for bright band. What is the condition when bright band will forms? Okay, bright band means intensity should be maximum. Okay, intensity should be maximum. Then for the purpose, we know resultant intensity that we got is 4 I naught cos square 5 by 2. Okay, from that, in order to get the intensity as maximum, what should be the phase difference between the two light waves? Okay, condition for the bright band I am going to explain. For the purpose, condition for bright band means condition for constructive interference. Okay, bright band when will forms? In the constructive interference forms. Then constructive interference condition is what? When constructive interference occurs. Constructive interference. Constructive interference means in that intensity should be maximum. Okay, when intensity will be maximum? Do you know the intensity equation? What is the intensity equation we got here? 4 I naught cos square 5 by 2. Intensity should be maximum. And for the purpose, intensity depends upon the phase difference. I is equal to, we know, 4 I naught cos square 5 by 2. Right. Intensity should be maximum in the constructive interference. Then for the purpose, the phase difference should be equal to phase difference. Phase difference if phi is equal to either you take 0 or 2 pi, 4 pi, 6 pi and so on. You substitute any one value in this. First 0 you substitute here. If you substitute 0 at here, cos 5 by 2, cos 0 value is 1, then cos value will become 1, then you will get the cos 5 by 2 for all these values. Cos 5 by 2 you will get as plus or minus 1, then cos 5 by 2 is maximum, then automatically intensity also maximum. Intensity also maximum, right? In order to get the intensity as maximum, then what is the maximum value of intensity at here from this? From I is equal to 4 I naught cos square 5 by 2. From that we will get intensity as 4 I naught we will get. Then the general equation we write as the phase difference as phi is equal to we write as 2n pi. Okay, this is the phase difference condition, and to get the bright band, n is equal to 0, 1, 2, 3 n values. And now path difference, how much it will be there? Path difference, phase difference between the light rays are this 2n pi. What is about the path difference? Path difference between the two light waves. Path difference between two light waves to get the bright band or the constructive interference. Then the path difference relation we know here. Previously we know the phase difference is equal to 2 pi by lambda into path difference. This is the formula we derived previously. We know that one. Then from that path difference, if you want delta x is equal to we write as lambda by 2 pi into phase difference we write, and lambda by 2 pi into phase difference is what at here 2n pi, and here 2 pi will gets cancelled, and we will get as delta x path difference. Okay, that is delta x is equal to n lambda, very important condition in order to get the bright band. This is the condition for the bright band where n value is 0, 1, 2, 3 and so on. Okay, then delta x value, how much you will, what values you will get? 0, lambda, 2 lambda, 3 lambda, 4 lambda and so on. Okay, in this you substitute. These are the path difference values. This is the condition for the bright band. Next condition for the dark band. When dark band will be forms, or the when destructive interference will forms. I am going to erase and again I will continue. Are you watching clearly? Any doubt you are having? You can ask me. No one is replying yet. Are you following or not? Okay. Okay, nice. Next condition for the dark band I am going to write. What is the condition for the dark band? Condition for dark band or destructive interference. Dark band forms in the destructive interference. Destructive interference. Okay, destructive interference in the dark band will forms. What is the condition for the dark band? Okay, condition for the dark band means intensity should be zero. Intensity should be minimum, right? Dark band means intensity should be minimum. Okay, intensity should be minimum. Minimum means it should be zero. Okay, you see here intensity formula previously what you got here, I is equal to from equation 5 we got as intensity I is equal to 4 I naught cos square 5 by 2. From that intensity should be minimum means cos 5 by 2 value should be equal to 0. Then if you substitute the values pi, 3 pi, 5 pi and so on, for all these values you will get cos 5 by 2 is 0. If cos 5 by 2 is 0, then from this I is equal to we have 4 I naught cos square 5 by 2. From that intensity 0, minimum, intensity minimum means dark band. Intensity minimum means dark band will form. This is the condition for the dark band. Then we can generalize that one. Okay, generally we write as the phase difference is equal. What you will get? You substitute the pi value it here. Okay, we are taking the phase difference as pi. Cos pi by 2, cos square pi by 2. Pi means 180 by 2. Cos 90 you will get. Cos 90 is 0. That means intensity you will get as 0. What about the phase difference? Phase difference we will get as phi is equal. General equation we write here. That we will get as 2n minus 1 into pi you will get. This is the condition. This you write as equation 8. Where n values are, here n values are not 0. It started from 1. 1, 2, 3 and so on. You substitute n value 1 here. 2 into 1 minus 1 pi. Pi you will get, and next 2 you substitute 2 to 4 minus 1 into pi. 3 pi you will get is equal to 3 pi, 5 pi and so on. We wrote this, we write general equation like this. I want the path difference for the bright band. Path difference is what? We know path difference is equal to delta x. Path difference between the light waves is equal to lambda by 2 pi into phase difference. Then lambda by 2 pi into phase difference is what at here? 2n minus 1 into pi. This will cancel. And finally, we will get the path difference condition as 2n minus 1 into lambda by 2. If you simplify this, n minus 1 into lambda. Right, these conditions you should remember. And this equation we can consider as 9. And here if you write delta x value set here, where n value is 0, 1, 2, 1, 2, 3. Okay, n value is 1, 2, 3 in that. And if you substitute n value 1, 2, 3, we will get delta x value as, if you substitute the 1, we will get lambda by 2, 3 lambda by 2, 5 lambda by 2 and so on. These are the path difference values in order to get the breadband. Okay, and now uh, finally one last graph I am going to draw, right? That is the variation of intensity with the position, with the distance. Okay, Take the screenshot and note it. Next one graph is a variation of intensity. Okay, I am going to draw the graph between the intensity and path difference. How intensity versus path difference graph will be there. I am taking the intensity on y-axis, path difference on x-axis. You may take the path difference or the phase difference on x-axis. Okay, intensity on y-axis, resultant intensity. And let us draw the graph, how we will get. And the graph will be very simple. The graph you will get like this. You will get the graph like this. This is at 0. This is at lambda by 2. This is at lambda. This is 3 lambda by 2. Okay. 5 lambda by 2. This is 2 lambda. Lambda by 2 will be increased everywhere. This is 2 lambda. 5 lambda by 2. This is again lambda by 2. Lambda. 3 lambda by 2. 2 lambda. Okay. This is the bright band. Intensity maximum at here. Intensity maximum. And this is the dark. You see here, this is the dark. This is the dark band where intensity is minimum it is 0. This is the variation of intensity with path difference graph. Okay. After 5-minute break, I will again continue. I'm going to end the stream and again I will start.